And that's not necessarily true, but it's not entirely without merit. When a framework or a capability, a component grows, it does tend to expand, right? So thus enter Spring Boot. About 3 years ago, Spring Boot went live in production. As it says here, you can go from 0 to app in under 5 minutes. Spring Boot gives you a lot of capabilities, a lot of ways to easily consume all of the capabilities of the Spring framework very nicely and neatly. I show you that as we go along. Spring Cloud, as it says, is designed for fragile infrastructure in partnership with Netflix. Anyone here of Netflix? Is anyone here a Netflix subscriber? Okay, the rest of you just save yourselves, don't subscribe. There's too much good stuff out there. But fragile infrastructure. The internet, as we think of it, is pretty reliable, right? But that doesn't mean that every part at every time is reliable and always online. Netflix creates a lot of great software and open sources it. Sometimes we work with them from the get-go, from the initial stages. Sometimes we take what they've developed and abstract from that and apply it a little more broadly, because Netflix deploys everything to Amazon Web Services. So we like to, in the Spring community, like to bring that open, some of those capabilities, and allow you to deploy them to different clouds, like Cloud Foundry, like Azure, like Google Cloud Platform. Sometimes we work with them up front, sometimes down the road, but we have a really great respect for Netflix engineers, and they love Spring as well. So, okay, when you're creating a microservices architecture, you're adding some complexity, right? Because you no longer have this single monolithic application that kind of does everything. So you need a few different things to help make your microservices more communicative with each other, so they know where to find each other and how to address each other and so on, to enable them to communicate. You also need certain capabilities that allow us to reason about our microservices architecture. A colleague of mine calls us meatware because we're walking sacks of meat, I guess. But some of these components serve one or both purposes. So I'm going to kind of go down the list rather quickly because I don't want to take a lot of time on this before we get into the live code, because that's the fun part, right? But when you create a microservice, you don't ever really just create a microservice. You create several because they work together to accomplish a task. And one of the concepts in the 12 factors for deploying applications to the cloud, I usually call out a couple of them as kind of primary importance. All of them are important, but the two that I kind of lean on the most are externalizing your configuration, so that if you had to open source your code today, you wouldn't be exposing credentials. It also has the very nice effect that when you have to change a location of a backing service, for instance, that you don't have to rebuild and retest and redeploy your code. You externalize that into a separate configuration. Spring Cloud Config provides that capability. When you do that, typically you wind up with something like the key value pair, right? That's text. And what do we use every day to store text, to version control and audit text? We use things like Git or SVN, but it's 2016, so usually Git. Spring Cloud Config sits on top of a Git repository and serves those properties up to any microservices that contact it and ask for its set of properties. Netflix subscribers. The application, netflix.com, when you go to it, that's fed by a bunch of microservices, kind of a cluster of microservices, about 500. Each of those is not running solo on the internet at any given point in time. There are multiple instances of each one of those. So in a monolith, if you're trying to load properties and you externalize that, you have one load. But in a microservices world, you have multiple instances of multiple microservices that need to get their properties and possibly even have their properties refreshed while they're live. That's what we use things like Spring Cloud Config Server for. And I give you a really quick glimpse at that as we go. And again, happy to talk about any of this at length after the fact. You also need a way for your microservices to see and be seen, so that each instance can find a backing service, for instance. And that backing service, these microservices are ephemeral. So one instance may die here and be replaced with another one here. So you need to have a way that each of these consuming microservices can find an instance of a backing service. That's really what a service registry is for, like Eureka. You also have things like a circuit breaker. You need to be able to, if a backing service falls offline, if it collapses, if a network connection is dropped, you need to be able to degrade gracefully. From Netflix, if you ever lose your recommendation engine, you never just see an empty bar across the middle of your screen. You won't see recommendations for you, but you might see these are movies that are popular in your area this week. It gracefully degrades, it steps down. And you can chain these, so you can actually go down several layers before you finally just go, hey, I give up, I can't do anything, this is all you get. But even then, you can provide sensible defaults. That's where things like Hystrix comes in as a circuit breaker. Ribbon provides client-side load balancing, so again, you're not inserting a new bottleneck into the process. Netflix Zool, if you're familiar with your Hittite mythology, or maybe even just Ghostbusters, Zool allows you to do intelligent routing and to externalize that from your applications as well, so that you're not rebuilding any time a backing service location changes. And then I touch on Spring Cloud Stream with asynchronous messaging because there are times that you don't want to block. You don't want to wait for a response. You don't need to. We're probably not going to have time for tracing, but that's a very key element in microservices because you need to be able to tell what your baseline is. When you have a series of actions that occur across multiple microservices, you need to be able to determine what is a normal time frame for that to occur, and when it falls outside that, to be able to establish that that is a problem. And of course, security is a key element as well. So that's kind of the very quick overview. So I'm going to launch into code, if that's okay. Yeah, everybody hates code, right? Okay, so let's jump out of that. And our journey with Spring Boot microservices kind of starts here. I'm getting wound up already. I'll have to open that up a little. Hopefully I don't lose my mic here. Okay, it starts here with the Spring Initializer. You may have heard it referred to affectionately as start.spring.io. The Spring Initializer is accessible from the Spring command line interface or from curl or right here. I usually go to the web portal because it's so pretty, right? I mean, that's, oh, you can't see a thing. That's really rude. Let me fix that. We have the technology. Wow, that's ugly. The screen's small, but we can make that work. Okay, let me scale that back down a little so we at least can kind of see what we're doing. Okay, you have options. Sometimes you hear Pivotal, Spring, Cloud Foundry referred to as opinionated. What does that mean? Well, in the old days of a framework or a platform, you did it one way. If you had something you needed to accomplish, you did it one way and one way only, the way of the platform, the way of the framework. And if you wanted to do it another way, you were just out of luck. The nice thing about an opinionated approach is if your use case falls within that 80 to 90% use case, you're covered. And it's very easy to get work done very quickly. If your use case falls outside of that 80 to 90% use case, maybe in that 5 or 10% that gets a little sketchy, we still want to get out of your way so you can get it done. It's just may take you a few extra steps. But we try to make it as easy as possible for most of the use cases. So with the Spring Initializer, that's what you see. You see sensible defaults. So you can create a Maven project, or if you're a hipster, you can create a Gradle project. You can choose your version of Spring Boot. So you have a couple of production versions as well as multiple snapshots. And then you can choose your dependencies and name and things like that. Just to give you a really quick look, if I switch to the full version, you see some of the other options available to you. You can choose jar packaging, and this is another factor of the 12 factors where you bundle your dependencies. You bring your dependencies with you, or as I like to say, you bring your toys with you. Because that way you always know what you have. You're not relying upon an application server and libraries that are loaded by an admin who may not have gotten something quite right. You can, if you're still stuck in that application server world, you can deploy as OR. It just violates one of the 12 factors, so we don't usually encourage that. You can choose your Java version, so 1.6.2.1.8. You don't even have to use Java. You can use Groovy or Kotlin, but who wouldn't want to use Java, right? The rest of you just leave now. Okay. Has anyone ever played the game of whack-a-mole where you have multiple dependencies and for some reason something just doesn't work? And you spend hours or days searching Google and Stack Overflow and playing with things and nothing. And finally you realize that version 3 of library A doesn't work with version 7 of library B. And you roll library B back to version 5 and everything just works. So congratulations, you're the poor slob who just discovered a new conflict. That's great, right? except you just lost a week. Yeah, that's not so great. But based upon the version of Spring Boot you choose, there are dependencies that are battle tested with that version. So you can go through the list and kind of see some of the dependencies, some of the libraries that are tested with version, in this case, 1.4.2 of Spring Boot. And you can choose off the list from several of these. It's opinionated, so you can still bring your own. You can still specify your version if you want to, but you don't have to. No more whack-a-mole if you're using any of these. I usually don't go through the list and check the boxes individually. I switch back to the simple version, and it's just kind of nice and easy to do this. So we'll start by creating a config service, if I can type. And I'll specify a config server dependency and generate the project. Now, this doesn't generate code per se. I mean, it'll create your main application class, but it creates a project with a POM and your dependencies. Excuse me. And it zips it all up nicely so you can download it and open it up and start actually coding. And that's what we're going to do. So I save it locally, and I open it up, and I pop it open in my favorite IDE. I won't ask what everyone's favorite IDE is. I don't want to start any kind of like food fight here. But we'll just pretend everyone loves IntelliJ. So, the first thing we'll do is go to our application.properties. This is a sensible defaults properties file that Spring Boot consults upon application initialization. And we're going to specify just a couple of sensible defaults for our config service. We're going to specify the server port it'll start on, and then we're going to specify our Spring Cloud config server get URI. This can point at a Bitbucket or a GitHub or a GitLab repo. It can point at a local Git repo on a network drive or on your laptop. Probably production, not your laptop, but for a demo works pretty well, so we'll go with that. So I'm going to point that to home/dev, demos, YAML, microservices, typing counts, services/config. Okay, now I'm going to ask those of you in the front row, I'm going to put in typos intentionally just to see if you're paying attention, okay? So if there are any typos here, it's all on you. I'm talking to you guys right here in front. So I'm just kidding. The faster I go, the more typos I get. So if you catch something, just shout me down, and we'll fix it early. Otherwise, we'll fix it later. Okay. So we'll annotate this as a config server, and boy, that's huge. Let me scale this down a little bit because I wasn't expecting the resolution to be quite like that. Yeah, I have it in biggest. We'll just take it back to bigger. We'll see if that works better. Better? I like that better. I can actually see a little more screen, so that's cool. Okay, so what we've done is we've created or edited a couple of properties, and we've added an annotation. So we're going to start this. Has anyone ever heard that Java is very verbose and there's a lot of boilerplate? Okay, we're going to just shatter that myth today. All right, that's just kind of a side effect. That's not the main intention, but let's have fun with it. So we're starting up here, and let's pull up our browser, and let's do this. And oh, did we not start? We didn't start. Well, that's awkward. So you can always tell a live demo when something breaks, right? Okay. Let me check to make sure I don't have a typo. Are you guys already letting me down? Okay, that all looks good. Wow, you're killing me. No, that's right. Oh. Okay. Let's try that. Okay. Whew. Had me a little worried. Once in a while, you know, there's some weird typo that's really hard to find, or once in a while there's an updated set of bits that comes down and I get surprised live. That's always fun. One time I was giving a walkthrough one evening, and they just dropped new bits. And I didn't really think about them pushing them to Spring Initializer just yet. So I was moving along fat, dumb, and happy, and bam, everything broke. Nobody could spot the problem. So I managed to work around it, went home, and just stayed up and worked on it until I figured out what it was. It was regression. The nice thing about a distributed team is that a colleague in Poland actually had it fixed by the time I woke up the next morning. So that was kind of nice. Okay, this is one of those things with Google Chrome that it keeps disabling my pretty extension here. So let me fix that. JSON view. It really hates that. Okay, so now let's. Oh, that's much nicer. Okay, so now this is a look at what is served up by our configuration service, right? So I actually skipped ahead a little bit. This is what you see as far as the backend repository for your config server. You can use properties files, which are just key value pairs. You can use YAML files if you want to structure things a little bit nicer. I do in this case. And you create different properties files based on what your microservice identifies itself as. So for every microservice that contacts the config service and asks for a set of properties, it will get properties loaded up from our application.yaml file or application.properties file. If it identifies itself, for instance, as an edge service, it will also get properties based on those specified for edge service. You can specify as well properties based on profile or platform. So you see things like application-cloud here. But this is kind of, let me zoom back out. Whoops, okay. So this is what you see here. For the edge service, these are the properties that a microservice instance identifying itself as an edge service would get from the config service. So you see specific, or you see more general properties here and more specific properties here. Now what happens if you have a conflict, right? Well, your more specific wins. So anything that's defined twice, if it's specific to an edge service in this case, it will override anything that may have been defined as just a plain application or a microservice. So it's not terribly sexy, but it's really handy. It's very essential to your microservices architecture. So I usually start with that. Let's take it a step further. Let me do a Eureka service, a service registry. And we're not going to need to specify the dependency for config server, but we will specify our config client dependency so it can retrieve its properties from our config server. And we will also include the dependency for a Eureka server. And how am I doing on time? I just want to make sure I don't run out. Okay, not bad. I will speed things along. If I get talking too fast, please let me know. I don't want to just blast through. I mean, I'd rather cover less and cover it well, and everyone feel like they got something out of it than just go, you know, it just ran off at top speed. So, okay, same routine. We open it up in our IDE. A little bit different path at this point, though, because now that we're going to be getting our properties from our config service, we need to get out ahead of our application initialization. Upon application initialization, it will look for application properties or application.yaml. But if we want to get out kind of ahead of that in the Bootstrap phase and tell it to look for a config service to get its properties, we need to do something else. So we provide a Bootstrap Top Properties file. So I'm actually going to find that, our application.properties. And you can have both, but there's really no good reason to do that. So I'm going to rename that just Bootstrap Top Properties, and we'll provide a string.application name, Eureka Service, and we'll point it to our config service, localhost 8888, and we'll go back to our main application class. We'll enable Eureka Server, and we'll start it. Again, we're killing ourselves with all this typing, right? Tons of boilerplate. I mean, you've already, in just a few minutes, with typos and everything, created a config service and a service registry. So you might as well just take the rest of the week off, right? Just tell your boss, I'm exhausted, I've worked way too hard, I'm going home. So I guess the first thing we see, it's updating port to 8761. It's pulling that from our config service, as you can see here. So we're pointing it at 8761. So we know it's working. But let's go ahead and take a look at it. This is too large. This is our Eureka Dashboard. The dashboard itself serves no purpose for your microservice. It's for us, so we can see what's going on inside our system, right? Our distributed system. And there is a lot of good information here, but kind of the two key points. One is your replicas. I'm not running this in a highly available configuration, so there are none at this point, and there won't be for the demo. But in production, you wouldn't do that. That said, even then, if your service registry goes offline, you're architecting for failure, right? You want your microservices to be operating and continue operating even if your registry goes offline. It will do that. You also see here the instances registered with Eureka. These are your microservice instances that are registering with Eureka and available and visible. Right now, there are none, so let's fix that. Now's where it gets fun, right? Because now we've created our infrastructure, if you will, our basic infrastructure. Now we're going to create the stuff that's using it. Is anybody here a fan of movie quotes or like clever, pithy quotes of any kind? You are my new best friend, okay? The rest of you, I don't know. You're killing me. You're making me feel so weird. Okay, well, anyway. We're going to have a drink later, okay? You like coffee? Coffee? Beer? Coffee and beer? Okay, all right, we can do that. All right, so let's add a few dependencies that we're going to need. We're going to create a quote service, like a quote of the day. Does nobody really here have a quote of the day application on your phone or anything? God, okay, well, anyway. I have two, because I have no life. But, okay, so we kept our dependency for our config client. We're going to be pulling our properties from our config service. We also want to expose a web API. We want to be able to register with Eureka so we can see and be seen with this microservice. And since we're storing and retrieving quotes, we need to provide some way to do that, right? I'm going to use JPA because, as a colleague of mine likes to say, I sometimes make poor life choices. I'm going to use H2 as my backend data store. It's just an embedded in-memory database. It's very fast and easy to use on a demo, but again, limited uses in production, please. And I'm going to include REST repositories. This allows you to use Spring Data REST. And again, it's an opinionated approach to creating repositories with data stores behind. It's very nice. It also allows you to expose REST APIs based upon those repositories for the price of a dependency, a free dependency. So that's in there. I'm also going to include HateOAS, hypermedia as the engine of application state. I know some of you may pronounce that differently. You're pronouncing it wrong. I'll just tell you that now. As someone who's worked with a product in the past called OAS, I can tell you that HateOAS is the right pronunciation. The HAL browser, which is a hypermedia access language, it's an internet draft right now, but it allows you to exercise your REST endpoints without creating your whole app. Your browser does. The nice thing about it is it provides context-sensitive links, so you can build your application around the links that are exposed when they make sense to be exposed. The best example I can think of is an Amazon shopping cart. If you place 3 things into your shopping cart, you can't request a refund for one. You haven't bought it yet. So if everything is built properly around links that are exposed only when they're supposed to be exposed, then that link won't even present itself to your application to show to the end user. Once the end user has purchased something, then obviously they would be able to see a link for returning a product. Okay, so we have that. I'm also going to bring in Rabbit. Let's see, anything else? That's probably good. Yeah, that's good. Sure, let's generate the project. And we'll save it. You know the routine now. Minor variations on a theme. We open it up in our IDE. Take a drink. Click it again because I didn't click it well enough the first time. And then we'll go to our application properties. We'll rename that again to Bootstrap Properties. And then we'll provide, again, a few different bits of information. Like our application name, we'll make this a quote service. And our config URI, again, we're pointing to our config server. 8. No typos, right? Okay. And we're going to enable Discovery Client, which this is an annotation, which actually I'm going into that a little bit earlier than I want to, so I'll come back to that. But this allows it to register, this microservice to register with Eureka. We're going to create an entity. This is just a JPA annotation for an entity class. That's not a Spring annotation at all. So we'll call this class quote. It is a quote service after all. We'll create a few meaningful fields, member variables, like quote text and quote source, and we'll create a constructor, no arg, for JPA and JSON, marshalling and unmarshalling. We'll create another actually useful constructor, and we'll create some getters. I was chatting with a friend of mine not that long ago, and he said, you know, I don't even know how it came up. We were talking about getters and setters. And he said, you know, I like to refer to them as accessors and mutators because I feel it makes me sound smarter. So if that makes you sound smarter and you like it, go for it. I don't. It takes too long to say. So we'll create a toString, and we're almost there. The fact that this is a JPA entity, we need to provide the information on how or which member variable corresponds to our key field in our underlying data store. And we need to somehow specify how that value will be created in our underlying data store. So this gets us part of the way there. Let's create a repository REST resource. This is just extending an interface. We'll call this, quote, repository. Boy, people must really hate quotes. I hope to change that here today. I want you to go out and download a quote of the day application. If nothing else, forget microservices, just download a quote of the day application. I'm kidding. Okay, so we're going to extend a predefined repository in Spring Data called CRUD repository, which gives you, as you might expect, capabilities for create, read, update, and delete. We'll define it in the context of having a quote for our entity and a long type for our ID field. And this is enough to get us going, but we have a problem, right? If we're going to test this, we have no test data in there at this point. So I always like to populate a little bit. This wouldn't go into production. Some of the things I do are not best practices for production, but I usually try to point that out. So if you have any questions and think, why in the world did he do that? Ask me. It's probably something that I'm demoing just to make the demo more clear. But what I'm going to do is create a command line runner bean, which will kick off and run a few little critical things in this case. Is anyone here a Java 8 user? Okay, so single abstract method, functional interfaces. I'm going to provide the implementation for our run method. Oops. And since it takes me way too long to type these, I'm just going to copy paste them in. But I need to inject our quote repository so I can actually save those. Repository? Front row. Come on. Ori. Okay. So now I have to go back down here and find this. You let me mistype. Okay. We'll fix this. We have the technology. Okay. So we now have a quote repository. Everything's happy now. And because I like to see what's going on, I usually do something like a find all, for each, system.out, print line, so we can see what's going on. That's always kind of nice. So now we're going to populate this with some initial data so we can see kind of what's happening. Oh, front row. All right, we'll try this again. Clearly the next time I need to go with the second row, right? Yeah. Front row is falling asleep on me. You guys are quote haters too? Gosh. All right, so we're up and running, and as you can see, we have the quotes that are being populated. But let's not take our word for it. Let's go check them out. Localhost. Now, before we actually check the quotes themselves, I wanted to give you a quick tour of the HAL browser. This is what I was mentioning earlier. It allows you to navigate and test your REST endpoints without creating your whole app. So the fact that you had a quote entity defined, it creates a collection of quotes and exposes them at endpoint quotes. You can also navigate to each of those here. And you can do things like get. You can do a non-get, so you can do a delete or a put. And again, you can test this out kind of nicely. Free dependency. But as you can also see, we can go directly to our endpoint. So we can pull up our quotes that way. And this is kind of what a hypermedia structure looks like. And you can navigate, of course, directly to a particular quote, so on and so forth. But this isn't a very good quote application at this point, right? It just gives us all quotes or a quote that you choose. But a quote of the day should be something random, something neat that we don't know what we're going to get. So we're going to do that. And I know you're terribly excited about this, I can tell. But bear with me. So those of you who are not happy about quotes. So we'll create a REST controller, and we'll call it class quote controller. How are we doing on time? We're good. And we will create a request mapping for random. So we will public quote get random quote, and now we'll return something. We need to inject our quote repository. And now we run into a problem, right? Because we're out of that 80 to 90% use case. We need to be able to provide some way of getting some kind of random quote. I'm going to create a very crude way of doing that here using @query, something like select q from quote q order by rand. So we get a random order listing. We'll define the signature for that. List quote and get quotes random order. And that way, we can come down here and do something like this. Quote repository, get quotes random order, get 0, and we'll return it. Not pretty, but it works. Or it should work if I have no typos. So we'll take a look. And then we'll roll on into our front end. So as you can see, we still have the ability to pull up all quotes, but now we also should be able to pull up a random quote. Nice, right? Okay, that's our backing service, and that's great. But what happens if we want to create an edge service of some form? I'll go through and show you kind of some of the reasons why you might want to do that, and some of the other tools that come into play as you would do that as well. So let's create an edge service. We don't need to include JPA because we have our backing service that handles our repository at this point. We don't need H2. We don't need our REST repositories. But what we also will need is something like Hystrix so we can gracefully degrade. If our backing service goes offline, we want to still keep the lights on. We want to still keep everything flowing, something flowing to our end users. We also want to include our client-side load balancing tool, Ribbon, as well as Zool for intelligent routing. And I'll show you a little bit of that as well before we're done here. And I think that should be good. Let's go ahead and create our shell project, save it, open it. Okay, so let's go to our application.properties, and again, we will change that to bootstrap.properties, and we'll assign it a name, edge service, and we'll point it to our config service, and go here. A little bit different annotation in this case. We want to make this a Zool proxy so that we can leverage our intelligent routing, our externalized routing, so we don't keep our routing and everything inside our edge service. So when that changes, we don't have to rebuild, retest, redeploy. I'll give you a really quick look at that as well. This also, it's a meta annotation. So when you pull into this, you see that we're also annotating it as a discovery client. So it still registers with Eureka. We are including circuit breakers, so we can still use Hystrix. So really quickly, we will create a quote here, a quote class here. What typically happens in an edge service is it will gather inputs from the back end and it will munge those. It will somehow create a streamlined set of essential capabilities, essential data that it provides via an endpoint to your end devices, if you will, perhaps over a mobile connection. So you don't want to provide everything that you would on a local connection to an edge service served device. So in this case, I actually do pretty much a straight pass-through, but you know, being what it is, just want to be able to show you how it all works. So again, we'll create a set of member variables. We will, in this case for quote text, again, we'll reference source. We'll create, again, a NOR constructor, not for JP this time, but for JSON marshalling and marshalling, and a useful constructor, and getters, and setters. And by the way, does anyone here use Lombok? You don't even have to do all this, but it's, I mean, obviously IntelliJ makes it pretty easy. So we're done with that. So now we also need to, for the purposes of this demo, and actually this works as it is. I guess let me run that really quickly to show you. Even without defining anything, because we're using Zool. We've annotated this as a Zool proxy. So if I go here and look at our properties here, we've defined a couple of routes. And the first one is just a pass-through. You notice it's service registry aware. So we've registered a service in Eureka and called it quote service. So if we, here we go. So if in our edge service we access a path with QS whatever, it will, Zool is smart enough, or Zool proxy is smart enough to know to effectively pass that on to our backend service directly. That's what's called a microservice. And if you don't have to make any changes, if you're just passing things through, if you will, your work is done. So for instance, if you have, we'll load it up and take a look. Of course. What did I miss here? No. Oh, yeah, well, yeah, I even showed you that, and then I went right back and just skipped it. Yeah, sorry. Remember, QS is defined in there. It has to have that QS for it to know where to pass through. So if you take a look at it here, our backing service, and we go right to our quotes here, quotes, they look identical, right? Except for the link. There's some link translation done. That's your microproxy, and that's, again, a free dependency. It's including Zool. How much time do we have left? I'm getting the look. Okay, we've got just enough time to throw in a couple more things. This is good. Okay, so let's go back to our edge service, and we will create a REST controller. And we'll call this class quote controller. And we'll create a request mapping. And we'll call this random. Nope, we won't. We've already done that. We'll call this quotorama. Why not, right? Okay, we're going to make this a public quote, get random quote. And again, we're going to want to be able to leverage ribbon for load balancing. So we're going to create a load balance bean for REST template. This is actually, there we go, template, REST template, return new REST template. Okay. This is not typically something you would see in production. I like to show you this because it actually shows kind of the, I won't say inner workings, but it shows the steps that Zool goes through to provide that routing for you. So it's kind of, I kind of like to show it. So at this point, we're going to auto-wire in or inject in our REST template. And we'll return REST template, get for object, http://quote service. And you notice we're not providing a hard-coded path. We're using Eureka, again, leveraging Eureka for that resolution. And we'll return a quote. Class. Typing devolves quickly when I'm in a hurry. But this should do it, right? So let's take a look. And while that's coming up, let me just show you this. I've defined another path in our Zool routing called demo. You can call it anything you want, but any path on our edge service that starts with quote will automatically forward to something. In this case, I'm forwarding it to a local endpoint called quotorama, and you saw me create that. This allows me to actually go back and show you what happens from a local forward. We're doing a REST template get for object, which then hits Eureka, finds out where quote service is, finds an instance of a quote service, and then hits the quote service as well. So if all works, cross your fingers, live demo, we should be able to, of course, first hit the endpoint we've established directly. Oh, of course. Oh, I'm on the wrong. I'm on the back of the quote service. All right, quotorama. And of course, that works. We would expect it to, but it's always nice for validation, right? And then we just go to quote. And we can see here that that works. Because in our path that we've established, when we hit quote, it forwards to the local endpoint, which then does a get for object on our REST template, which hits our backing service. Again, Eureka aware. So there's a lot of other stuff I would love to cover, and I will happily cover it later. Or you can check out the stuff on YouTube that I have out there as well. But it's been great, the time that we've had. Again, our time together here is very limited. Our time afterward is not. So please do reach out to me on Twitter, mkheck, or email me. Happy to talk about this as long or longer than you'd like. So thank you very much for coming.